Okay, this is paired t-test scenario 2. This is the confidence interval for paired t-test scenario 2. So Professor Andy McNeil measured the time in seconds required to catch a falling meter stick for 12 randomly selected students, dominant hand and non-dominant. Professor Neil claims that the reaction time in an individual's dominant hand is less than the reaction time in their non-dominant hand. Create a 97% confidence interval for the mean difference and explain the confidence level. So I'm going to say we're going to go dominant minus non-dominant just because that's the way they listed this. Ultimately, I'll need to put this information in the column L1 and this information in the column L2. So the very first thing we have to do is we have to define our parameter, which is let mu d equal the true population mean difference, because we're going to be subtracting these. And we know this is a paired test because each individual was measured twice. So student 1 got measured with the dominant and then with a non-dominant, etc. Student 3, dominant and then the non-dominant. So they were all measured twice. We basically have 12 students measured 2 times. So we always have to include the order of the subtraction, which is dominant minus non-dominant. Our conditions for this course, we can just say that they were assumed. You may want to refer back to this when you get to college because they may require it, they may not. If they do, here it is, those conditions. All right, so once I've written that down, I need to go ahead and write my equation. And my equation is x bar d plus or minus t star SD divided by the square root of n. Bad thing is we don't know what x bar d is. We're going to have to get that. We don't know what SD is. We'll have to get that. We do know that n is 12 because we have 12 pairs of data. We're going to need our degrees of freedom, which is going to be 12 minus 1. And we're also going to need t star. And we'll calculate that here in just a moment. So here's how we're going to do this. We're going to take all this information. We're going to go to stat. I'll press the stat button in the middle of the calculator. And then I'm going to press edit. And I'm going to enter my data into L1 and L2. Now you notice I have column L3 filled in. If I have a column that I don't want filled in, I'm just going to arrow up and highlight it, press enter, then clear. The clear button's right here. And there it is. Press enter and it's cleared out. Now, as it turns out, this data right here is the one I want. I want L1, 177, 210, etc. Then I'm going to enter L2 right here. So I have my data that I want in L1 and L2, but I really don't want just L1 and L2. That's a nice list of data. I want the differences. So that means I need to subtract them. So I'm going to go second 1 minus second 2. And it's all filled in. Okay? So now it's all filled in. And it's like, well, how do I get X bar D and SD? Well, the quickest way I know, and there are other ways to do it, but the fastest way is to go stat, test, t-test, and make sure that data is highlighted. So you may have to arrow to the left, press enter. Because it's a paired test, all paired tests, it's not, I'm sorry, we're not doing a test. I'm sorry, we're doing a confidence interval. So stats test, drop down to number 8, which is a t interval. Again, make sure our data is highlighted. Our list is L3. If you had a 1 there, you're gonna have to go second 3. So second followed by the number 3. And it says we want to run a 97% confidence level, so 0.97. Now, I'm going to get some information I'm not ready for yet, but it's good information, so I'm going to go ahead and write it down. The first thing that they give me, and I don't need it just yet, is I have the actual interval, negative 0.025 to negative 0.0014. So I have the interval, but I also have X bar D, which happens to be 0.01316. I don't want to forget that negative sign. And then I also have SD, which is 0.0164. Okay. The only thing I don't have now is T star. So I need to go back and calculate T star. And to calculate T star is second vars inverse T parenthesis 1 minus 0.97 close parenthesis divided by 2. Degrees of freedom is 12 minus 1. And if you wanted to, you could just type in 11 and that'll work fine as well. And we ended up with a T star of 2.4906. 2.4906. All right. So I'm going to take that information and I'm going to plug that into my equation. So negative 0.0132 X bar D plus or minus my T star 2.49, my SD 0.0164 divided by the square root of 12. This is the interval that I calculated. And I told you I would need it. That's the interval. So we are 97% confident that the true population mean difference in reaction times, dominant minus non-dominant, lies within the interval negative 0.025 minus 0.0014. So in repeated sampling, we expect that this method will capture the true population mean difference in reaction time, dominant minus non-dominant 97% of the time. And if we notice, this does not include 0. For it to have included 0, we would have had to go from a negative to a positive. So 0 does not lie within an interval. Therefore, we are 97% confident that there's a difference in reaction time. Matter of fact, we are confident that the reaction time for dominant is less than non-dominant. Okay, we are 97% confident that the reaction time in dominant is less than non-dominant because we ended up with negative values. Awesome. Thank you for watching this, and the next video will cover scenario 3.